Over 250 million years ago, the face of the Earth was unrecognizable. The continents we know today had not yet formed. Instead, nearly all landmasses on the planet were fused together into a single colossal supercontinent known as Pangea. Stretching from pole to pole, Pangea was a vast and desolate sprawl of connected terrain, bordered by the enormous global ocean called Panthalassa. It was a time when the very geography of the planet shaped the course of evolution. Pangea's formation was not sudden. It was the final product of millions of years of tectonic movement, as smaller landmasses collided and merged into one. But once united, the consequences of such a massive continent were immediate and severe. Without vast oceans to moderate climate across its interior, Pangea became a land of brutal extremes. The central regions were hot, dry, and arid, dominated by windswept deserts and seasonal droughts. Only the coastal edges saw any moisture, delivered by rare rains carried from Panthalassa. This dry and hostile interior set the stage for one of the most dramatic evolutionary shifts in Earth's history. Life had long existed, both in the oceans and on land, but now it was faced with a new challenge, adapting to a world where survival was determined not just by competition, but by an unforgiving climate. Freshwater was scarce. Vegetation struggled to thrive. The few rivers that did exist were lifelines, attracting both prey and predator in a constant cycle of life and death. As Pangea stabilized, its size created not only environmental pressures but also new opportunities. Species that had once been separated by oceans were now brought together, forced to compete, migrate, and adapt in close quarters. Animals that had never encountered one another now shared the same habitats. Ecosystems overlapped. Territories were no longer isolated, but became zones of conflict, with stronger, more aggressive species dominating the weaker ones. Reptiles began to thrive in this new world. Their tough, scaly skin made them more resistant to water loss compared to their amphibian ancestors. They laid eggs with leathery shells that didn't need to be submerged in water, allowing them to colonize drier regions. Among them emerged creatures that would come to define the era, both in form and ferocity. These early reptiles were not yet dinosaurs, but they were no less formidable. They were survivors of a world shaped by scarcity, heat, and an ever-growing struggle for dominance. The scarcity of plant life inland also meant herbivores had to travel farther and risk more just to feed. This pushed them into exposed areas, crossing open ground under the gaze of unseen predators. The very layout of Pangea had created a deadly stage. Forests were few and patchy, shelter was unreliable, waterholes were predictable and crowded, and wherever the prey went, the predators followed. Pangea's size also slowed its geological activity. With fewer plate boundaries, there were fewer volcanoes and earthquakes compared to earlier times. But beneath the surface, pressure was building. The Earth's interior did not sleep. Magma pooled beneath the crust, biding its time. Though not yet a threat, these deep forces would later awaken with catastrophic consequences. Above ground, the world grew still and dry. Atmospheric oxygen levels were dropping. The air became harder to breathe. Temperatures fluctuated wildly between day and night, yet life persisted. Small mammal-like reptiles dug burrows to escape the heat. Amphibians clung to the remaining wetlands. Insects, vast and diverse, scurried across every surface. And towering above them all were the carnivores, agile, cunning, and growing ever more dominant. The geography of Pangea was both a prison and a proving ground. Migration routes were limited. Escape was nearly impossible. Species that failed to adapt vanished. Those that endured became more specialized, more aggressive, more efficient. It was a crucible of evolution. Prey could be seen from miles away. Shelter was a luxury. Predators learned to track, ambush, and outlast. Some evolved stronger limbs for long pursuits. Others developed keen senses to hunt in the twilight. Competition didn't just drive evolution, it escalated it. The land became a constant battlefield, where every advantage mattered and every weakness was punished. And yet, for all its severity, Pangea was a place of possibility. It connected the world. It gave rise to new lineages. It forced life to innovate. It was a world without borders, without isolation, without sanctuary. It was the stage on which life would rise, fall, and rise again. Deep in the canyons and dry basins, bones of the fallen began to collect. Some belonged to creatures never seen before, soon to vanish without a trace. Others would become legends of prehistory, the prototypes of giants yet to come. And in every footprint, in every fossilized tooth, the story of this era remained. An Earth transformed by its own design, testing the limits of life across a single, unforgiving continent. But the most important legacy of Pangea was still forming. In its unforgiving interior, a new kind of killer was rising, one shaped not just by hunger, but by dominance. Apex predators built for land, not sea, soon to rule with tooth and claw. And as their reign began, the ocean, once a vast and indifferent space, would become something else entirely. It would become the only place left to hide. In the vast, harsh expanse of Pangea, a new chapter in Earth's history was unfolding. The land was dominated not just by the environment, but by creatures that had adapted to thrive in its unforgiving conditions. Among these were the apex predators, animals that stood at the top of the food chain and shaped entire ecosystems through their power and presence. These predators were not mere scavengers or opportunists. They were relentless hunters, perfectly designed for killing, whose emergence would alter the balance of life on land forever. The rise of land predators during this period was a complex story of evolution, adaptation, and survival. It was a time when nature's brutal law survival of the fittest was on full display, where strength, speed, cunning, and sheer brutality determined who lived and who died. These killers evolved in an era when the Earth's climate was growing drier and more extreme, and they had to become more specialized to survive. One of the most striking groups of these predators were the gorgonopsids. They were mammal-like reptiles, distant ancestors of mammals, but they were far from gentle. Their name, meaning gorgon face, was fitting, for their skulls bore terrifying saber-like teeth that could slice through flesh with deadly efficiency. Gorgonopsids were among the largest and most fearsome hunters of their time, some growing as large as modern-day lions or even bigger. Their jaws were powerful, and their teeth designed to pierce and hold struggling prey. But gorgonopsids were not alone. They shared the land with other formidable predators like therocephalians and early archosaurs, all evolving different hunting strategies and physical traits. Therocephalians, for example, were smaller but highly agile, relying on speed and sharp teeth to catch prey. Some evolved strong forelimbs for grappling, while others developed enhanced senses to track their victims in low light or dense vegetation. These predators occupied various ecological niches, each carving out a place in the food web. Some hunted large herbivores, others focused on smaller creatures. Some were ambush predators, hiding and waiting for the perfect moment to strike, while others chased prey over long distances. The diversity of hunting styles was a sign of intense competition, pushing evolution forward in leaps and bounds. This competition was brutal. Resources were scarce, and the environment was not forgiving. Every hunt was a gamble, every meal hard-won. Predators often fought among themselves for territory and dominance. Battles between rival killers could be as deadly as their hunts. Injuries were common, and survival depended on both physical prowess and cunning behavior. The pressure to adapt was relentless. The anatomy of these predators reflected their lifestyle. Strong limbs, sharp claws, and powerful jaws were common features. Many had forward-facing eyes, providing depth perception critical for judging distance during a chase or strike. Their bodies were streamlined for speed or power, depending on their hunting strategy. Some gorgonopsids had elongated skulls and robust neck muscles, enabling them to deliver crushing bites. Reproduction and parenting were also factors in their survival. Some evidence suggests that certain predator species may have cared for their young, protecting them in nests or dens until they were capable of fending for themselves. This behavior would give their offspring a better chance in a dangerous world, allowing predators to maintain stable populations despite high mortality rates. The rise of land predators was closely linked to the prey species they hunted. Herbivores also evolved in response, developing new defenses and behaviors. Some grew larger or developed armor, such as bony plates or thick skin, to resist attacks. Others evolved speed or agility, learning to detect predators early and flee quickly. This evolutionary arms race between predator and prey shaped much of the diversity of life during this era. The landscape itself played a significant role in predator-prey dynamics. Pangea's open and dry terrain gave predators advantages. There were fewer places for prey to hide, making ambush hunting less effective, but favoring endurance chases and open combat. Predators had to be both fast and strong, able to sustain long pursuits or overpower prey quickly. The scarcity of water and shelter also meant animals had to be constantly on the move, increasing encounters between hunters and hunted. Waterholes and riverbanks became hotspots of activity. Predators would stake out these locations, waiting for thirsty herbivores to arrive. The risk was high. Prey were alert and could fight back, but the reward was worth it. These scenes of predation were brutal and frequent, a constant reminder of the power struggle governing life on Pangea. The rise of land predators also influenced the behavior of other creatures. Smaller carnivores and omnivores adapted to avoid direct confrontations with apex killers. Many became nocturnal or crepuscular, hunting at dawn, dusk, or night to escape the watchful eyes of larger predators. Burrowing and climbing became survival strategies for the vulnerable. The presence of dominant killers forced other species to innovate in how they lived and moved. Fossil evidence provides a glimpse into this violent world. Fossilized bones show healed wounds and bite marks, evidence of battles fought and survived. Trackways reveal hunting patterns and group behavior, suggesting some predators may have hunted in packs or family groups. These findings give scientists insight into the social structure and hunting strategies of these ancient killers. The rise of apex predators was not just a story of individual species, but of ecosystems in flux. As predators grew stronger and more numerous, they reshaped the populations of herbivores and smaller animals. This cascading effect influenced plant life as well, since herbivore numbers affected vegetation patterns. The balance of life on land was delicate and dynamic, with apex predators as its keystone. This era also set the stage for future evolutionary developments. The success of mammal-like reptiles paved the way for true mammals millions of years later. The evolutionary pressures of this time refined traits like efficient metabolism, sensory acuity, and behavioral complexity that would define later species. The legacy of these predators extends far beyond their own time. However, the dominance of land predators was not permanent. Environmental changes, such as shifting climates, volcanic activity, and later mass extinction events, would challenge their reign. These killers, adapted to a specific world, faced extinction or transformation as conditions evolved. Their story is both one of power and fragility, a reminder of nature's constant change. In conclusion, the rise of land predators during the age of Pangea was a defining chapter in the history of life on Earth. These apex killers were products of a harsh environment and intense competition, evolving remarkable adaptations that made them rulers of their time. Their presence shaped entire ecosystems, influencing prey species, landscapes, and the course of evolution. Their legacy echoes through the fossil record, a testament to the fierce and dynamic world that existed long before humans walked the Earth. In the sprawling supercontinent of Pangea, where land stretched vast and unbroken for thousands of miles, the struggle between predator and prey played out with relentless intensity. Unlike today's world, fragmented by oceans and varied habitats, this massive landmass offered limited refuges. For prey animals, survival became a matter of constant vigilance, agility, and adaptation, because simply put, prey had nowhere to hide. Pangea's geography was crucial in shaping this grim reality. Its enormous size meant large interior regions far from the coast, where rainfall was scarce, and ecosystems were dry, open, and often barren. Dense forests, thick jungles, and mountainous retreats, places that could offer cover or escape, were limited. Instead, vast expanses of deserts, scrublands, and sparse vegetation dominated. This open terrain made it easier for predators to spot prey from a distance and gave little protection against ambushes. Early in Pangea's history, herbivores evolved strategies to avoid predators, but the sheer scale of the land and lack of hiding spots made traditional escape tactics less effective. Animals couldn't simply disappear into dense forests or thick brush as many do today. Instead, they had to rely on speed, keen senses, and group behaviors to survive. Herding became a critical survival mechanism, allowing animals to watch for danger collectively and confuse predators with sheer numbers. But even group living was no guarantee of safety. Apex predators like the gorgonopsids and therocephalians were expert hunters, and some likely hunted cooperatively. This meant herds of herbivores were constantly under pressure, needing to stay alert and move continuously to avoid ambushes. Resting was dangerous. Sleeping was vulnerable. The constant threat shaped their daily lives and behaviors. Open landscapes also forced prey to evolve physical defenses. Some species developed thick, armored skin or bony plates to protect against bites. Others grew horns, spines, or sharp hooves as weapons. Speed was paramount, with long legs and strong muscles adapted for sprinting. Early ancestors of dinosaurs, for example, were fast runners, their lightweight builds allowing quick escapes. Survival was a race against death. The scarcity of water in Pangea's interior also played a significant role. Watering holes and rivers became critical hubs of activity, both for herbivores seeking hydration and predators waiting for an opportunity. These locations were deadly traps. Prey animals had to approach with caution, aware that predators lurked nearby. Often, predators would wait patiently for hours, hiding in nearby shade or tall grass, striking at the perfect moment. This situation forced prey species to become more intelligent and socially complex. Communication and cooperation were key. Animals developed warning calls, complex social signals, and even coordinated defense tactics. Some species formed protective circles or positioned the most vulnerable members in the center of the herd. Such behaviors show that the pressure from predators influenced not just physical evolution, but also the development of social structures and cognition. Despite all these adaptations, many prey species were still at a severe disadvantage. The relentless hunting pressure led to high mortality rates, especially among the young and weak. Natural selection was brutal, favoring only those who could outsmart or outrun their hunters. The fossil record shows evidence of bite marks and healed wounds, signs of repeated attacks and escapes. painting a picture of a dangerous world. The lack of hiding places also influenced migration patterns. Some herbivores likely moved seasonally, following scarce vegetation and water sources. This constant movement could mean crossing dangerous predator territories multiple times a year. Migration was a gamble, balancing resource needs against the risk of becoming prey. Success meant survival. Failure meant death. In contrast, the ocean offered a vastly different world. While land was dominated by giant killers and sparse cover, the seas were home to enormous marine reptiles and safer environments for many species. This difference further increased the pressure on land animals, concentrating life and competition in these harsh terrestrial environments. Evolutionary pressure from predator presence drove remarkable innovations in prey species. Some developed early warning systems, like highly sensitive hearing or smell, capable of detecting predators from great distances. Others evolved camouflage or coloration that helped them blend into the sparse vegetation. Behavioral changes, such as living in burrows or rocky outcrops, provided limited shelter but helped reduce risk. In the absence of dense forests or mountains, some prey species adapted by developing keen eyesight and fast reflexes. Eyes positioned on the sides of their heads allowed wide fields of vision to spot predators approaching from multiple angles. They learned to freeze or bolt at the first sign of danger, sometimes confusing predators with sudden movements or erratic flight patterns. The dynamics between predator and prey created a high-stakes environment that influenced the entire food web. Plants and vegetation were affected, as herbivore populations fluctuated. In some cases, overgrazing by herds seeking safe feeding grounds caused local desertification. In others, predator pressure helped control herbivore numbers, maintaining ecological balance. This delicate equilibrium was constantly shifting in response to the relentless chase for survival. It's important to understand that prey animals were not helpless victims. Their adaptations and behaviors allowed many species to persist for millions of years. Their evolutionary arms race with predators drove the development of complex traits that would echo into future lineages, including dinosaurs, mammals, and ultimately the species that inhabit the Earth today. The harsh realities of Pangea's land environment also highlight the incredible resilience of life. In a world where every shadow could conceal a predator, where water and shelter were scarce, and where the landscape offered few places to hide, life found ways to endure. The constant pressure shaped not only individual species but entire ecosystems, pushing evolution in directions that would define terrestrial life for hundreds of millions of years. In conclusion, the reality that prey had nowhere to hide on Pangea during the rise of apex land, predators paints a vivid picture of a brutal, dynamic world. Survival depended on speed, strength, cooperation, and constant vigilance. The absence of safe refuges forced both predators and prey into an ongoing battle that defined this period of Earth's history. This relentless struggle for life and death not only shaped the evolution of countless species, but also set the foundation for the complex terrestrial ecosystems we know today. During the era when apex predators ruled the land of Pangea, the ocean presented a starkly different environment. While the terrestrial world was a battlefield filled with constant danger, the marine realm offered relative safety for many species. This contrast arose from the fundamental differences in habitat structure, predator-prey dynamics, and ecological niches between land and sea. Pangea was a vast supercontinent, surrounded by expansive ocean basins that hosted a diverse array of marine life. These waters provided complex habitats like shallow reefs, deep basins, and coastal lagoons where creatures could find refuge and resources. Unlike the open, exposed landscapes of Pangea's interior, the ocean offered a three-dimensional space full of hiding places, cover, and escape routes. One major factor contributing to the relative safety of marine life was the vastness and complexity of the aquatic environment. Water itself slowed movement and provided physical obstacles that made ambush hunting more challenging. Predators in the ocean could not simply sprint after prey, as land predators did. Instead, they relied on stealth, speed bursts, or camouflage, but the fluid medium allowed prey species to evade capture by moving vertically as well as horizontally. Many marine organisms evolved specialized adaptations to maximize their chances of survival. Fish, cephalopods, and marine reptiles developed streamlined bodies for swift swimming, coloration for camouflage, and keen senses to detect threats early. Coral reefs and underwater vegetation created natural shelters where smaller species could hide from larger predators, and open waters offered places to disperse and avoid concentration. Compared to land predators, marine hunters had more limited means to pursue and corner prey. While powerful marine reptiles like nothosaurs and plesiosaurs existed, their hunting was often opportunistic rather than systematic. The ocean's fluid environment meant prey could quickly slip away into depths or complex underwater terrain, reducing the likelihood of sustained pursuit. Furthermore, many marine animals occupied distinct ecological zones, separated by depth and habitat type. This vertical stratification reduced direct competition and predator-prey encounters. Species adapted to deep, dark waters faced fewer predators than those near the surface, while reef dwellers benefited from the structural protection of coral formations. This mosaic of habitats created a more balanced ecosystem compared to the exposed land. The presence of abundant resources in the ocean also contributed to relative safety. Plentiful plankton, small fish, and invertebrates supported large food chains, allowing many species to specialize in feeding strategies rather than constant predator avoidance. In contrast, land herbivores often faced sparse vegetation and had to travel extensively, increasing their vulnerability. Marine life's relative safety was not absolute. Predation certainly occurred, and many species faced threats from apex aquatic predators. However, the ocean's environment created opportunities for survival strategies that were less available on land. The three-dimensional space, availability of refuges, and diversity of habitats made it possible for species to coexist with predators more successfully. This difference between land and sea ecosystems during Pangea's age influenced evolutionary pathways. Marine species developed a range of adaptations to exploit niches safely, while land species faced stronger selective pressures from constant predator threats. The ocean became a refuge for vulnerable groups and a source of evolutionary experimentation that would shape future marine biodiversity. Another important aspect was the mobility of marine species. Many fish and marine reptiles could migrate over vast distances, escaping localized dangers or environmental changes. This ability to move widely helped maintain population stability and avoid predator hotspots. In contrast, land animals were often confined to specific territories or migratory routes that exposed them to repeated predation risks. The oxygen-rich waters surrounding Pangea supported diverse life forms, from microscopic plankton to giant marine reptiles. This abundance created complex food webs where energy flowed through multiple trophic levels. In such systems, the presence of predators did not necessarily imply danger for all species equally. Many could thrive by occupying less risky niches or developing defensive behaviors suited to aquatic life. The ocean also buffered environmental extremes better than land. Temperature fluctuations, droughts, and wildfires were common challenges on Pangea's surface, but had less impact underwater. This stability made marine habitats more predictable and safer refuges during periods of climatic stress or ecological upheaval on land. The fossil record provides evidence supporting this relative safety. The marine deposits from the Pangea period show abundant remains of diverse species, with fewer signs of predation. trauma compared to terrestrial fossils. Bite marks and healed wounds occur, but mass predator-driven die-offs were less common than on land. This suggests marine species experienced less intense predation pressure overall. Marine ecosystems acted as evolutionary reservoirs where life could persist through harsh terrestrial conditions. When environmental changes or extinction events struck land species, ocean inhabitants often survived and later recolonized or diversified. This dynamic made the sea a vital component in the resilience and continuity of life on Earth. In summary, marine life during the time of apex land predators in Pangea enjoyed relative safety due to the unique characteristics of the aquatic environment. The complexity, vastness, vertical dimension, and resource abundance of the ocean created refuges and niches where prey species could avoid constant threats. While predation existed in the seas, it lacked the relentless, overwhelming intensity faced by land animals. This difference shaped the evolutionary history of both marine and terrestrial life, influencing adaptations, survival strategies, and biodiversity patterns. Understanding this contrast gives insight into how life responded to the challenges of Pangea's world and highlights the ocean's crucial role as a sanctuary amid the dangers of the prehistoric land. During the time of Pangea, the Earth's ecosystems were shaped by the presence of apex predators, both on land and in the surrounding oceans. These top hunters dominated their respective realms, but their hunting strategies, physical forms, and impacts on their ecosystems differed dramatically. Understanding the contrasts between land predators and marine apex predators reveals why the land was far more dangerous for prey, while the ocean offered relatively more safety. Land predators of Pangea were among the most formidable creatures to ever walk the earth. Giant theropsids, including gorgonopsians and therocephalians, wielded powerful jaws filled with sharp teeth, designed for crushing bone and tearing flesh. These predators were built for stamina and strength, capable of long chases or sudden ambushes. They ruled open and often barren landscapes, where prey had limited options for escape or cover. On land, predators relied heavily on stealth, speed, and brute force. The open terrain of Pangea gave them an advantage. With few places to hide, prey were visible from great distances. Ambush predators could patiently stalk herds, while pursuit predators could run down their targets over long distances. Land predators often hunted alone or in small groups, using calculated tactics to isolate weaker or slower individuals. In contrast, marine apex predators occupied a very different world. Enormous marine reptiles like pliosaurs, mosasaurs, and nothosaurs were among the ocean's top hunters. These creatures evolved streamlined bodies for fast swimming, powerful tails for bursts of speed, and sharp teeth for gripping slippery prey. Unlike land predators, marine hunters had to contend with a fluid environment where movement was three-dimensional and prey could escape vertically or horizontally. Marine predators generally faced different challenges in capturing prey. The ocean's density and currents limited their ability to sprint long distances at full speed. Instead, they often relied on ambush tactics, camouflage, and bursts of acceleration. Some used their large size to intimidate or crush prey, while others used sensory adaptations, such as enhanced vision or electroreception to locate food in murky waters. Another major difference lay in prey availability and diversity. The ocean contained vast numbers of smaller fish, cephalopods, and invertebrates that formed abundant, stable food sources for marine apex predators. This allowed many species to specialize and hunt specific prey types without exhausting resources. On land, prey species were more limited in number and diversity, often forced into open areas with scarce vegetation, increasing their vulnerability. Social behavior also differed between land and marine predators. Evidence suggests some land predators may have hunted in packs or coordinated groups, but this behavior was likely rare and opportunistic. Marine predators, on the other hand, were mostly solitary hunters, relying on stealth and power rather than teamwork. The vast ocean spaces and the difficulty of coordinating underwater hunting likely discouraged complex social hunting strategies. The impact of apex predators on their ecosystems also varied. On land, predators exerted extreme selective pressure on prey species, driving rapid evolutionary arms races. Prey had to evolve speed, defensive structures, and social behaviors just to survive. Predation was intense and constant, shaping not only individual species, but entire terrestrial ecosystems, influencing plant life and habitat structure through the cascading effects of predator-prey interactions. In the marine environment, while predators were still influential, their effect on prey populations was generally less severe. The three-dimensional nature of the ocean and the abundance of resources reduced direct confrontations and allowed many species to coexist. The ocean's complexity buffered prey from constant danger, enabling greater biodiversity and more stable population dynamics compared to the exposed terrestrial world. The physical constraints of each environment dictated predator adaptations. Land predators needed strong limbs, endurance, and stealth to track prey across open terrain. Marine predators evolved efficient swimming appendages, hydrodynamic bodies, and sensory systems adapted to water's optical and acoustic properties. These differences highlight how the environment shaped apex predators' hunting strategies and survival tactics. Another important factor was reproduction and juvenile survival. On land, young prey animals faced extreme predation risk with limited shelter, often resulting in high mortality rates. This intense pressure influenced reproductive strategies, favoring large numbers of offspring or rapid growth to escape vulnerability. Marine species benefited from the ocean's protective habitats like reefs and underwater vegetation that offered nurseries and hiding places for juveniles, increasing survival chances. Climatic and environmental changes affected predators differently as well. Fluctuating temperatures, droughts, and habitat shifts could drastically alter land predator territories and prey availability, causing population stresses. The ocean's relatively stable environment provided refuges and continuous resources, allowing marine predators to maintain populations more steadily through changing conditions. In summary, the contrast between land and marine apex predators during Pangea's era reflects the profound influence of environment on evolutionary paths. Land predators were relentless hunters, exploiting open landscapes where prey had minimal shelter, resulting in brutal survival pressures. Marine predators, adapted to a fluid, three-dimensional habitat, faced different challenges and exerted less overwhelming pressure on prey populations. This dynamic made Pangea's land a more dangerous place to live, where the threat of predation was constant and intense. Meanwhile, the ocean's complex habitats and abundant resources provided a relative refuge, allowing many species to thrive despite the presence of powerful marine hunters. Understanding these differences deepens our appreciation for the diverse strategies life evolved to survive in prehistoric worlds. During the turbulent age of Pangea, when powerful apex predators ruled the land, prey species faced relentless threats to their survival. In response to the constant danger, many herbivorous and smaller animals developed complex herding and group defense strategies. These social behaviors became essential adaptations that enhanced survival odds by leveraging numbers, cooperation, and collective vigilance. Herding is a widespread survival tactic seen across numerous terrestrial animals, and during the Pangea period, it played a crucial role in reducing predation risk. By grouping together, individuals could benefit from the safety in numbers effect. A larger group meant more eyes and ears to detect approaching predators early, increasing the chances that members could flee or prepare for defense. One of the key advantages of herding was early warning. When a predator approached, a single individual might not notice, but many animals scanning the environment simultaneously improved detection. Alarm calls, sudden movements, or coordinated fleeing alerted others, often allowing the entire herd to escape before the predator could strike. This collective vigilance reduced individual risk dramatically. In addition to early detection, herding also confused predators. Large groups moving together made it harder for a predator to single out and isolate one target. This confusion effect, sometimes called the dilution effect, meant the chance of any one individual being caught was lower. Predators had to expend more energy and face greater uncertainty, often causing them to abandon hunts or target easier prey. Some Pangean herbivores likely formed tightly packed groups where the most vulnerable, such as young or injured, were protected inside the herd's center. Stronger, more alert members surrounded them, creating a defensive perimeter. This spatial arrangement increased protection for weaker individuals and maximized the herd's overall chance of survival. Group defense went beyond simply running away. Some species evolved coordinated defensive behaviors that involved physical confrontation or intimidation. When threatened, animals might display aggressive postures, loud vocalizations, or even attack predators as a unified front. Such collective action could deter predators or force them to reconsider risky attacks. For example, certain armored herbivores developed protective shells, spikes, or horns that they used in group defense. Standing shoulder to shoulder, these defenses became more effective, presenting a wall of deterrence to attacking predators. The visual impact of a united group showing these physical traits could discourage even the most determined hunter. Herding and group defense also influenced predator strategies. Predators adapted to cope with these defenses by developing tactics like hunting in smaller groups to isolate individuals, stalking to wear down herds over time, or ambushing from hidden locations. This evolutionary arms race drove both prey and predators to refine their social and hunting behaviors. The formation of herds likely affected migration patterns as well. Large groups moved together across Pangea's vast landscapes to find food and water, balancing the needs for sustenance and safety. These migrations sometimes covered great distances and required careful coordination to avoid fragmentation and vulnerability to predators. Social bonding and communication were vital components of herding. Animals developed signals such as vocal calls, body language, and scent markings to coordinate movements and maintain group cohesion. Such communication ensured rapid responses to threats and smooth cooperation in complex environments. Fossil evidence and comparisons with modern analogues provide insight into these behaviors. Trackways showing multiple individuals moving together, fossilized nests near herd sites, and preserved injuries consistent with predator attacks suggest that Pangean animals lived in social groups with shared defense mechanisms. These clues reveal the evolutionary importance of cooperation in prehistoric survival. Herding and group defense were not without costs. Large groups required more resources, increased competition for food, and greater visibility to predators or parasites. Balancing these trade-offs was critical, leading to variable group sizes and flexible social structures depending on environmental conditions. In the marine realm during Pangea's time, group defense strategies were less common due to different ecological pressures and environmental factors. The three-dimensional aquatic environment made maintaining tight groups more difficult, and marine prey species relied more on camouflage, speed, or refuge habitats rather than collective defense. This contrast highlights how habitat shaped social behaviors. The success of herding and group defense during Pangea contributed to the evolutionary pathways of many species, fostering social complexity and cooperation that would echo through later periods. These behaviors laid foundations for the social structures seen in mammals, birds, and other animals millions of years later. In conclusion, in a world where apex predators dominated Pangea's land, herding and group defense strategies were critical survival tools. Through collective vigilance, confusion of predators, protective physical traits, and cooperative behaviors, prey species increased their odds of survival in a perilous environment. This social adaptation was a key factor that shaped the balance between predator and prey during this tumultuous chapter of Earth's history. During the age of Pangea, life on land was a relentless struggle for survival. Apex predators stalked the vast landscapes, their presence a constant threat to prey animals. In this dangerous environment, the ability to escape predators was often the difference between life and death. Over millions of years, prey species evolved a variety of escape tactics and physical adaptations designed to evade, outpace, or outsmart their hunters. One of the most fundamental escape tactics was speed. Many Pangean prey animals developed elongated limbs, lightweight bodies, and powerful muscles to run quickly and sustain long chases. Speed allowed animals to put distance between themselves and pursuing predators, especially in the open terrain that characterized much of Pangea's supercontinent. Running fast, however, was only one aspect of escape. Agility and maneuverability became equally important, as predators often relied on bursts of speed and ambush tactics. Prey animals evolved the ability to make sudden sharp turns, quick stops, and rapid changes in direction to evade capture. This agility was often supported by flexible spines, strong limb joints, and sensitive balance organs. Camouflage was another crucial adaptation. Many species developed coloration patterns that blended with the surrounding environment, making it harder for predators to spot them. This included muted earth tones, disruptive patterns that broke up body outlines, and countershading, where the belly was lighter than the back to reduce shadows and make animals less visible from different angles. Some animals relied on crypsis not only visually, but through behavior. Remaining motionless or moving slowly in the presence of predators helped avoid detection. This tactic was especially effective when combined with camouflage, as many predators rely heavily on movement cues to spot prey. The environment of Pangea shaped these adaptations. Open plains, sparse forests, and barren rocky areas provided limited cover, so speed and camouflage were essential. In contrast, denser vegetation offered more opportunities for hiding, and some species evolved behaviors like freezing or hiding in burrows to escape predators. Burrowing itself became a significant escape strategy. Several Pangean animals adapted to dig tunnels or seek refuge underground, where larger predators could not easily follow. Burrows offered protection not only from predators, but also from harsh weather conditions and environmental extremes, providing a safe haven for raising young. Defensive structures also played a role in escape tactics. Animals developed spines, armor plates, and thick hides that made them harder to catch or injure. While these adaptations were not escape methods in the strictest sense, they increased survival chances by deterring predators or surviving attacks long enough to flee. Some prey species evolved startling display tactics designed to confuse or intimidate predators at close range. Sudden flashes of bright colors, loud noises, or threatening postures could buy precious seconds for escape. These displays exploited predator hesitation, giving the prey an advantage when flight was still possible. Sensory adaptations enhanced escape abilities as well. Acute hearing, sharp vision, and sensitive smell allowed prey to detect predators early and choose the best moment to flee. Some animals developed wide-set eyes for panoramic vision, reducing blind spots and improving the ability to scan for threats while grazing or resting. Behavioral adaptations complemented physical traits. Prey animals often adjusted activity patterns to avoid predators, becoming nocturnal or crepuscular if predators were primarily active during the day. Others altered their feeding locations and routes to minimize encounters with hunters. Migration was another large-scale escape tactic. Some Pangean herbivores moved seasonally to regions with fewer predators or more abundant resources, reducing predation pressure and improving survival. Migration required coordination, memory, and the ability to navigate complex landscapes, all impressive feats in the context of Pangea's vast and changing environment. Juvenile animals were especially vulnerable and often had specialized escape adaptations. Rapid growth rates allowed them to quickly reach sizes less susceptible to predation. Some young species developed defensive spines or temporary coloration patterns that differed from adults, providing extra protection during early life stages. Predators, in turn, countered these escape tactics by developing their own adaptations, driving a continuous evolutionary arms race. Faster running speeds, enhanced senses, and improved ambush strategies kept prey under constant pressure to refine their evasion skills. In comparison, marine animals in Pangea faced different escape challenges. The ocean's three-dimensional environment required rapid bursts of swimming speed and vertical maneuvering. Fish and marine reptiles developed streamlined bodies, powerful tails, and fins optimized for quick acceleration and sharp turns. Some used camouflage and schooling behavior to confuse predators, while others relied on hiding in reefs or murky waters. However, the constant threat from apex marine predators was generally less acute than on land. Water offered more hiding places, and prey species could disperse widely, reducing encounters with hunters. On land, the stark, open landscapes made escape far more difficult, increasing the importance of sophisticated escape tactics and physical adaptations. In conclusion, the rise of formidable land predators during Pangea forced prey species to develop a wide array of escape tactics and adaptations. Speed, agility, camouflage, burrowing, startling displays, and sensory enhancements all contributed to survival in a perilous world. This complex interplay of predator, pressure, and prey adaptation shaped the evolutionary trajectory of terrestrial animals, setting the stage for future ecosystems. During the turbulent era of Pangea, when the land was dominated by relentless apex predators, the ocean offered a rare sanctuary, a refuge where life could find safety and relative peace. While terrestrial environments became battlegrounds filled with constant threats, the vast and complex marine world provided hiding places, escape routes, and a less hazardous existence for many creatures. Understanding the ocean as a refuge during this period reveals crucial insights into how life adapted to survive under pressure and how ecological dynamics shifted between land and sea. Pangea, the immense supercontinent, created dramatic landscapes on land with harsh climates and competitive ecosystems. But its surrounding oceans remained extensive and diverse habitats with far greater three-dimensional complexity. The water column, coral reefs, seagrass beds, kelp forests, and underwater caves offered countless niches that shielded many species from the dangers that plagued terrestrial life. One of the main reasons the ocean served as a refuge was the physical environment itself. Unlike the open plains and exposed surfaces of Pangea's land, the underwater world provided shelter through vertical and horizontal spaces. Prey species could quickly retreat into crevices, swim to deeper waters, or exploit murky zones where predators had difficulty following or hunting effectively. This spatial complexity made escaping or avoiding predators more feasible. The ocean's fluid nature also gave marine animals an advantage in movement and escape. Swimming in 3 dimensions allowed for rapid changes in depth and direction, offering more options for evasion than the relatively 2-dimensional surface of the land. Fast-swimming fish, agile cephalopods, and powerful marine reptiles could utilize bursts of speed or complex maneuvers to outpace predators or vanish into hidden refuges. Schooling behavior was another key factor that made the ocean a safer place, Many fish and marine invertebrates formed large, coordinated groups that confused predators and diluted individual risk. The vastness of the ocean combined with schooling often prevented predators from successfully singling out targets, unlike on land where dense herds were more vulnerable due to limited cover. Marine prey also used camouflage extensively. Transparent bodies, countershading, and reflective scales helped many fish blend into the shifting light patterns underwater. Some species mimicked the appearance of poisonous or unpalatable organisms, reducing the likelihood of attack. These adaptations, combined with the ocean's physical complexity, made detection and capture by predators challenging. Additionally, the ocean's environment allowed for unique chemical defenses. Many marine animals produced toxins or foul-tasting substances to deter predators. Coral reefs hosted poisonous sponges and cnidarians with stinging cells, which created hazardous zones that predators avoided. This chemical warfare was largely absent on land during Pangea's era, giving marine life another layer of protection. The ocean's productivity also contributed to its role as a refuge. Rich nutrient upwellings and vast plankton populations supported diverse food chains that did not rely solely on hunting large prey. Filter feeders, scavengers, and detritivores thrived, providing multiple survival strategies that were less risky compared to the direct predator-prey confrontations common on land. Unlike terrestrial animals forced to migrate long distances across exposed terrain to find food and water, marine creatures could often exploit more stable resources in localized habitats. This reduced the need for risky journeys that increased vulnerability. Marine animals also used seasonal vertical migrations, moving to deeper or safer waters during predator-heavy periods, further enhancing survival chances. Reproductive strategies in the ocean added another layer of security. Many marine species produced large numbers of offspring with planktonic larval stages that dispersed widely, reducing localized predation pressure. The vastness of the ocean meant young animals could drift away from dangerous areas, increasing the odds of survival until maturity. In contrast, terrestrial reproduction often involved laying eggs in exposed nests or raising vulnerable young in highly competitive environments. This difference made the ocean a comparatively safer nursery for many species during Pangea's era, supporting continued population growth and diversity. Fossil evidence supports the idea of the ocean as a refuge during this time. The diversity of marine fossils, including numerous small, delicate species, suggests relatively stable and safe ecosystems. By contrast, fossil assemblages from land show frequent injuries and signs of predation, highlighting harsher survival conditions. This dynamic influenced evolutionary trajectories. Marine animals faced less intense predation pressure and thus evolved different life strategies. Many invested energy into growth, reproduction, and specialization rather than constant defense or escape. This allowed the ocean to maintain high biodiversity and complex food webs. The ocean also served as a source for recolonization of land after mass extinctions or environmental crises. Species that survived in the marine refuge later adapted to terrestrial habitats as conditions changed, carrying traits that had evolved in safer waters. This interchange between ocean and land shaped long-term biodiversity patterns. It's important to note that the ocean was not entirely free from danger. Apex marine predators like giant sharks, marine reptiles, and cephalopods hunted aggressively. Yet, the complexity and vastness of the ocean environment gave prey more options and opportunities to avoid predation compared to the more exposed terrestrial world dominated by massive land predators. In conclusion, the ocean during Pangea's era acted as a critical refuge from the relentless predation pressure on land. Its three-dimensional spaces, camouflage opportunities, chemical defenses, schooling behaviors, and stable resources created a safer haven that allowed marine life to flourish. Understanding this refuge role deepens our appreciation of how ecosystems balance survival and adaptation in the face of extreme challenges. During the era of Pangea, life faced stark choices about where and how to survive. The land and the sea presented fundamentally different environments, each with unique challenges and opportunities. The rising dominance of apex predators on land made terrestrial life perilous, while the ocean provided refuge but demanded its own specialized adaptations. These contrasting pressures created survival trade-offs that shaped the evolutionary paths of countless species, forcing them to balance risks and benefits in an ongoing struggle for existence. On land, the presence of massive and efficient predators created an environment of constant threat. Herbivores and smaller animals were under intense pressure to develop defensive traits or flee quickly. However, life on land also offered access to new food sources, nesting sites, and niches that the ocean could not provide. Plants thrived in sunlight and soils, creating rich terrestrial food webs that supported diverse animal communities. Surviving on land required overcoming challenges such as exposure to harsh weather, scarcity of water, and the need for mobility on uneven terrain. Animals had to evolve lungs for breathing air, strong limbs for movement, and tough skin or coverings to prevent dehydration and injury. These adaptations came with energetic costs. Moving on, land generally required more energy than swimming, and exposure to temperature extremes meant animals had to regulate their body heat or risk death. Meanwhile, the ocean presented a vastly different set of survival conditions. Water provided buoyancy, reducing the energetic cost of movement. Swimming allowed animals to traverse large distances with less effort compared to running or climbing on land. The three-dimensional aquatic environment also offered abundant hiding places and escape routes from predators. However, life in water also required specialized adaptations. Animals needed gills or efficient lungs to extract oxygen, streamlined bodies to reduce drag, and fins or flippers for propulsion and steering. Saltwater posed osmoregulatory challenges, requiring mechanisms to maintain internal fluid balance. Sensory adaptations were crucial, as visibility underwater varied with light and turbidity, demanding acute detection of movement, vibrations, and chemical cues. These environmental contrasts led to trade-offs in survival strategies. On land, animals prioritized defenses against physical attack, rapid escape, and endurance in variable climates. In the ocean, animals focused on maneuverability, stealth, and exploiting the vertical space of water columns. These differing priorities shaped morphology, behavior, and life history traits. For example, terrestrial animals often invested heavily in limb development for speed and agility, as well as armor or weaponry for defense. Marine species, conversely, emphasized body shape and fin structure for efficient swimming, with many relying on camouflage, schooling, or chemical defenses to avoid predators rather than direct confrontation. Reproductive strategies also reflected survival trade-offs. On land, species typically produced fewer, larger offspring with greater parental care, adapting to environments where offspring faced high predation risk and resource competition. In the ocean, many species produced vast numbers of tiny eggs or larvae that dispersed widely, betting on quantity to ensure some survived in a safer but more unpredictable environment. These trade-offs influenced lifespans and growth rates. Terrestrial animals often developed slower growth and longer lifespans, investing energy in individual survival and social structures. Marine animals, benefiting from relative safety and mobility, frequently exhibited faster growth, earlier maturity, and shorter lifespans, allowing rapid population turnover. Another significant trade-off involved sensory systems. Land animals developed complex vision and hearing to detect predators across open landscapes, while marine animals refined lateral line systems echolocation, or bioluminescence to navigate and avoid danger in murky or dark waters. These adaptations impacted behaviors and social interactions, further differentiating survival strategies. The interplay between these trade-offs also affected habitat preference and mobility. Some species specialized in terrestrial niches with few aquatic competitors, while others exploited coastal zones or estuaries, balancing exposure to predators with resource availability. Certain amphibious animals evolved to move between environments, negotiating the risks and benefits of both realms. Migration patterns illustrated survival trade-offs vividly. Marine migrations often spanned thousands of kilometers, allowing animals to exploit seasonal resources and avoid predators. On land, migration was more limited by physical barriers and predator territories, but still critical for accessing food and breeding grounds. Climate and environmental changes during Pangea further complicated these trade-offs. Fluctuations in temperature, sea levels, and habitat availability forced species to adapt or relocate. Those with flexible survival strategies that balanced land and sea adaptations had an advantage, sometimes leading to evolutionary innovations or speciation events. Fossil records reveal examples of species that shifted their lifestyles in response to these trade-offs. Some marine reptiles evolved stronger limbs and lungs, gradually becoming semi-aquatic or fully terrestrial. Others retreated entirely to the sea, abandoning terrestrial challenges. These evolutionary experiments highlight the dynamic tension between land and sea survival pressures. Understanding survival trade-offs between land and sea during Pangea helps explain why biodiversity evolved along such divergent paths. It illuminates how environmental constraints and predator-prey dynamics sculpted life's form and function. It also offers perspective on modern ecosystems, where species continue to negotiate similar trade-offs in an ever-changing world. In summary, the contrasting environments of land and sea during Pangea created profound survival trade-offs. Animals had to weigh risks of predation, resource availability, energetic costs, and reproductive success. These pressures drove evolutionary innovation, shaping the morphology, behavior, and ecology of species across both realms. Recognizing these trade-offs enriches our understanding of life's resilience and adaptability through deep time. The era of Pangea was defined by the rise and reign of apex predators that dominated the land with unmatched ferocity. These formidable hunters shaped ecosystems, influenced evolutionary paths, and left a legacy that echoes through time. Understanding the legacy of Pangea's apex predators reveals how these ancient giants sculpted biodiversity, impacted ecological balance, and set the stage for future life on Earth. Apex predators are species at the top of their food chains, with no natural predators themselves. During Pangea, these creatures were powerful, large, and highly adapted to hunting and dominating prey. Their presence created a world where survival was a constant battle, shaping behavior, physiology, and community structure. One of the most significant legacies of Pangea's apex predators is their influence on evolutionary pressures. The intense predation risk they imposed forced prey species to develop sophisticated defense speed, camouflage, armor, and complex social behaviors. This arms race between predator and prey drove rapid evolutionary change, increasing biodiversity and specialization. These predators also controlled population dynamics by limiting prey abundance, preventing overgrazing and maintaining balance in ecosystems. Their hunting behaviors helped shape vegetation patterns and nutrient cycling, demonstrating the interconnectedness of all life forms. Without apex predators, ecosystems tend to become unbalanced, leading to cascading effects known as trophic cascades. Fossil evidence from Pangea's period reveals the diversity and specialization of apex predators. Giant theropod dinosaurs, massive amphibians, and early archosaurs dominated various regions, each adapted to their environment with unique hunting strategies. Some used speed and agility to chase down prey, while others relied on ambush tactics or overwhelming strength. The physical adaptations of these predators were remarkable. Powerful jaws with sharp teeth, muscular limbs for speed and grappling, keen senses for tracking prey, and behaviors such as pack hunting or territoriality all contributed to their dominance. These traits influenced not only their survival, but also their reproductive success and territorial control. The legacy of Pangea's apex predators extends beyond their direct ecological impact. As the supercontinent began to break apart, these predators influenced the evolutionary trajectories of species on the newly forming continents. Isolated populations adapted to different environments, sometimes giving rise to new apex predators or allowing prey species to evolve in predator-free environments. This evolutionary legacy can be traced through the lineage of modern predators. Birds of prey, large carnivorous mammals, and reptiles all carry genetic and behavioral traits that originated during Pangea's apex predator era. Understanding these connections helps clarify how ancient life forms contributed to today's biodiversity. The extinction or decline of many Pangea apex predators during mass extinction events also left ecological voids. These gaps allowed new species to emerge, diversify, and occupy roles previously dominated by giants. This process of ecological succession reshaped ecosystems and opened opportunities for evolutionary innovation. The cultural and scientific legacy of Pangea's apex predators is profound. These creatures have fascinated humans for centuries, inspiring myths, art, and scientific inquiry. Studying their fossils and ecological roles provides valuable insights into past environments and informs conservation efforts by illustrating the importance of apex predators in ecosystem health. Modern conservation biology recognizes the crucial role apex predators play in maintaining ecological balance. Lessons learned from Pangea's apex predators reinforce the need to protect today's top predators to prevent ecosystem degradation and loss of biodiversity. Their legacy serves as a reminder of the delicate balance that sustains life on Earth. Furthermore, Pangea's apex predators influenced behavior and social structures in prey species, encouraging group living, cooperation, and communication. These social adaptations enhanced survival and shaped complex animal societies observed today. The predator-prey dynamic catalyzed cognitive and behavioral evolution across multiple taxa. In conclusion, the legacy of Pangea's apex predators is multifaceted, encompassing evolutionary, ecological, cultural, and scientific dimensions. Their dominance forged pathways for biodiversity, influenced ecosystem function, and shaped life's history. By studying their impact, we gain a deeper understanding of life's resilience, the importance of predators, and the ever-changing nature of Earth's biosphere.